In this video, we're going to solve a system of linear equations. First, we're going to give you a little bit of background of this type of question, so what we are actually solving for. And from the previous chapters, we learned y equals negative 3x minus 15. That is that if we graph it, we're going to get a straight line. And 3x minus 2y equals negative 9. It's also a straight line. So these two straight lines, they might intersect. So if they intersect, they will have intersection point. So the first equation can be graphed as a straight line. The second one is also a straight line, and the straight line may have intersection point xy. So that's what this system, the solution of this system is. So the final answer we found, x equals something, y equals something, will tell us what this intersection point is. But we know actually if we have two parallel lines, they may not have any intersection point, which means after you solve this, you're going to find out that we don't have any solution. But there is another case that these two lines may be the same line, and you will find that they have, if they are the same line, every point is going to be an intersection point. You will have infinite many solutions. So there are actually three possible cases, but most of the problems we're going to solve will be the first case, and there is exactly one intersection point. Okay, so now we're going to look at how to solve for this intersection point. So there is a geometric meaning. Although we solve the equation algebraically, and this answer is actually the intersection point of these two lines. All right, so now let's look at how we solve this type of system. So when we have two equations together, we call this a system of equations. Usually we use parentheses to put them together and to indicate they are one problem. It's not two problems. We're not solving one by one. We're solving these two together. So typically there are two ways to do. One of them is called the substitution method, and the other is called the elimination method. And so we are going to look at both ways. Now, first, substitution method, obviously it means we plug something into the other. And notice that in the first equation, in this system, the first equation, y is given as an expression of x. So we can plug this y, let's highlight this y, into the second equation. So in the second equation, 3x minus 2y, and this y, we're going to replace it with the whole expression. And because what's y? Y is the same as negative 3x minus 15. So when I see this y in the second equation, we're going to replace this y. Again, this y is the same as that y, and that y is the same as negative 3x minus 15. So I'm going to replace it, and we're going to get equals negative 9. Okay, so we plug the first equation into the second equation, or in other words, we substitute negative 3x minus 15 for this y there. Now, notice after we plug it in, we got an equation with only one variable x. Y disappears. So that's what the good thing about substitution. Originally, we have two variables, x and y, but after we plug it in, x disappears, y disappears. We only have x. And that is the equation we learned at the beginning of the semester. So now we just get rid of parentheses by distributing negative 2. So negative 2 times negative 3, that's going to be positive 6x. Negative 2 times negative 15, that's going to give us positive 30. And keeping equals negative 9. And combine like terms, that's 9x equals minus 30. And we're going to subtract 30 from both sides. That's going to give us negative 39. You can do this in two steps if you want. And now we get rid of 9 in front of x. So that's going to give us negative. We can reduce this fraction a little bit by dividing both of them by 3. So we have negative 13 over 3. And notice that when we solve a system, we need to solve for both variables, not only x, but also y. So the answer should look like x equals something, y equals something. So right now, I only got the answer for x, which is negative 13 over 3. And now, how do we find a y? Well, what we can do is we can plug negative 13 into the first function. So let me put it on top of the problem. So we replace this variable x with negative 13 over 3 because we already found out what x is. So let's do negative 3 times negative 13 over 3, subtract 15. That's going to give us negative times negative. It's going to be positive. And 3 cancels that 3. So that gives a positive 13 minus 15, which is negative 2. So y should be negative 2. Okay, and if you want to double check your answer, you can plug them back in there, both x and y into the first equation and into the second equation. They should satisfy both equations. All right, so similarly, we can solve the second one. But in the second one, notice that in both equations, y is not given. So if we want to solve it by substitution method, we first need to solve for y. So we can either choose the first equation and try to solve for y, or you can choose the second and solve for y. So it's up to you. So I'm going to pick the first equation and get y. Solve for y means getting y by itself. I'm going to subtract 4x from both sides, and that's going to cancel, and y equals negative 4x plus 16, or 16 minus 4x. So now I'm going to take this y and plug into the second equation. So we have 5x minus, by the way, make sure you put parentheses for this y, because we're replacing y with this entire expression, which is negative 4x plus 16. So make sure we put them in the parentheses. And equals 11. Okay, so we substitute negative 4x plus 16 for y. And now we solve it the same way as we did. Distribute the negative sign to both of them in the parentheses. And now we combine like terms. 9x minus 16 equals 11, and we add 16 to both sides. So that gives us 9x equals 27, and divide both sides by 9, we get a 3. And now, how do we find y? So we're going to plug 3 into the second expression, into the y expression. So we're going to get negative 4 times 3 plus 16, and that's going to be negative 12 plus 16, and that is 4. So the final answer should be x equals 3 and y equals 4. And by the way, we don't always have to solve for y and plug y into the other equation. We could solve for x, but notice that in both equations, solving y is a little easier because all we have to do is to subtract x from both sides. If we try to solve for x, let's say we have to move y to the right side and we have to divide both sides by 4, which can create fractions. So I can show you a little quick here. And so first we subtract y from both sides, and we're going to end up with, let's see, 4x equals 16 minus y. And then we have to divide both sides by 4. And that gives us a fraction. So we got to plug this fraction into the second equation for x. That's just causing, we don't like fractions. It's sometimes this is unavoidable. But in this case, we're lucky because there's not a number in front of y, which is 1. So we can leave y by itself. We can get y immediately without dividing any number in front of y. Okay, so usually the tip is we solve for the variable with the coefficient with a number equal to 1 in front of the variable. But if we say I put a 2 here, then we don't have option. We'll put a 3 here. We don't have option. We'll put a 2 here. Then we have to get a fraction and deal with the fractions. Okay, all right. So now we can, we will, in the next video, we're going to look at how to solve those by the other method, the elimination method.